Section 3.1, Graphing Linear Equations, Day 2 lesson. Our essential question is, how do you identify the x and y intercepts of a linear equation? So how do you identify the x and y intercepts of a linear equation? We have 3 new vocab words. The first one is standard form. Standard form you'll see more about on the next slide. Standard form is a very specific order that an equation could be written in. Ax plus by equals c. And on the next slide, you'll see all of the specifics about what the a, b, and c really represent. The x-intercept and the y-intercept. In order to answer the essential question, you have to understand what these 2 vocab words mean, what they mean. The x-intercept. The word intercept is very close to the word intersect. So the x-intercept is where your line crosses the x-axis or intersects with the x-axis. And remember, the x-axis is the horizontal axis. You can probably guess what the y-intercept means then. The y-intercept is where your line crosses the y-axis. You might be wondering, and the y-axis, of course, is the vertical axis. You might be wondering, why do we need to know this? What are we even talking about? Well, yesterday in the day 1 lesson, we learned how to take an equation and make a table and then use that table to graph the equation. And then we figured out if it was linear or nonlinear, and we figured out if it was a function. Now today, we are going to talk about a different way that you could go about graphing an equation. So we're not going to necessarily make a T-chart table where we've got to plug in 5 values for x and solve it. We are instead going to use just two points to graph our line, and those 2 points are called the x-intercept and the y-intercept. So this is an alternative to the graphing method that we used yesterday. And believe me, we will show you a lot of different ways that you can come about getting a graph to represent an equation in algebra. So it won't just be 1 or 2. We will have lots of different opportunities for you when it comes to graphing. Okay, now, before we move on to something totally new, we've got a couple click and drags for you that kind of go with what we did yesterday. Now, what we happen to find out in class, of course, is that students go right for the picture graphs, of course, and they can tell which ones are linear and nonlinear. No problem at all. So, those are the 5 graphs. Now, after that, we ask you to really think about the graphs from your notes at the beginning of this section, the 3 that we did in your notes, and then the 8 that were on your worksheet. And what we hope to see is that students recognize that linear graphs have the variable x in them, and they don't have any exponents on that variable x. They don't have any absolute value. They don't have square roots. They don't have exponents that are the variable, and they don't have fractions with the variable on the bottom. All of these things over here create different kinds of nonlinear graphs, and that's what we were hoping for you to see. In your notes, we had one that had a V shape. That would be the absolute value graph. We had a quadratic that was similar to that. There was a parabola shape. That would be the exponent of a 2. We had on your worksheet an exponential graph where something grows very rapidly, like this. We had a square root function that curves more like that. And then last but not least, we had a variable on the bottom of the fraction, and this one created the most I would say a graph that was by far different from the rest because it had two completely separate pieces. The one on your worksheet looked something like this. It had two curves, and it never actually touched or crossed any axis, not the x-axis or the y-axis, not at all. So this one maybe needs to move a little bit over like that. But that's called a hyperbola, where you've got two separate curves that are in opposite quadrants like that. So those are all nonlinear. So the regular equations with x, just a plain x, you could have a coefficient that's a fraction, or a positive or a negative number. Those were the ones that were linear. Here's a second click and drag, just like that last one that we used in class, just to get more students involved. Okay, now, what does a linear equation look like? What does it look like? Well, we said a linear equation might look like this, where it's just got a plain x in it. Nonlinear, we saw lots of ideas. Nonlinear could be a square root, it could be an exponent, it could be an x that's an exponent, it could be absolute value, or it could be a fraction with the variable on the bottom. Those are 5 different things that we saw on your worksheet that cause their graphs to be nonlinear. How do you determine if it's a function? If it's a function, we do the vertical line test. We always do the vertical line test when we're looking at a graph to determine if it's a function. Okay, now back to that standard form that I promised you. Standard form is ax plus by equals c. There's a very specific order there. So you've got to have your term with the x first, then your term with the y, then the equal sign, and the c is just a plain number. A must be a whole number, so 0, 1, 2, or 3, and so on. B and c are integers, so that means that they're positive or negative, like for example, -2, -1, 0, 1, 2, and so on. So A, B, and C. So I think about it like A, B, and C, they're all numbers, okay? They're all numbers. A can't be negative. A can't be negative. B and C, they can be negative. But because we said that they had to be integers, that means no fractions, no decimals are allowed. Integers are like the numbers on a number line. A just has to be positive, like a positive integer. B and C can be positive or negative integers. And that order is super specific. So you look at like a train track, on the left-hand side, you've got to have both of your variables, x and y. The C, is, that's the only thing on the right-hand side, that is a number. It's an integer, positive or negative number. Okay, we're going to try this out. So we've got 6 different examples here, 6 different examples. And we want to see if you can recognize if any of these are written in standard form, following all of the rules that I just talked about. All of the rules. So, here's the first one. The first one, if I compare it, I think it's written in order. It's got the x and the y on the left side of the equal sign, but there's a little problem there. There's one little problem, and that is that A cannot be negative. So A needs to be positive. So that means that this first one is not written in standard form. So not written in standard form. Okay, the next one. The next one, if I compare, I look at where my equal sign is, definitely not in standard form. These 2 terms are in the wrong places. Wrong places. So wrong order, So this is definitely not standard form. The next one. Looks like it's in order. Look at where my train track would be. X, Y. I've got a negative on the 2. C can be negative. It was just A that can't be negative. So I think I found my first winner. Yes, that one is in standard form. This next one that's blue, I can look at this one right away. Definitely in the wrong order. Look at where the train track is. Everything's on the wrong side. Both of these are supposed to be over here, and the plane number is supposed to be on the right-hand side, so that is not in standard form. Next one. I see one problem with this one. My X and Y, they're on the correct side, but we said no fractions are allowed. We are talking about integers. Positive for A, positive or negative for B and C, so not standard form. Last but not least, the one that's in red, standard form, definitely. It's in order. A is positive, B is negative, C is positive, perfect. Okay, so standard form. Why are we focusing on standard form? Because we are going to teach you how to use standard form with your intercepts to graph. That's what we're going to be working on. Now, intercepts. We said it's where your graph crosses the X and Y axis. So look at the graph. How do you find the intercepts from a graph? See that line that's in blue? What are my intercepts? Well, here's my x-axis. So this point right here, 500. 500 is my x-intercept. And then on my y-axis, my y-intercept is 2,000. So my y-intercept, my graph touches the y-axis at 2,000. Then I need to answer the question using the labels, what do the intercepts mean in this graph? Well, we're talking about pouring peanuts. We're talking about the weight and the time. So what this means is that we have a container that's full of peanuts and we are pouring them out. We are pouring them out. So right here, the weight was 2,000 ounces. So my y-intercept, the container started out with 200 ounces of peanuts. Oh, sorry, 2,000. 2,000 ounces of peanuts. That's what that graph is telling me, that's where it started out. It had 2,000 ounces of peanuts in it. Then when you get all the way down here to the bottom, to my x-intercept, 500, I look at that label, and that label says time in seconds. So after 500 seconds, what happened? What happened? At 500 seconds, look over here, 0 is the weight. So after 500 seconds, the container was empty. It was empty. So the first intercept, up at the top, up here, I started out with 2,000 ounces of peanuts at a time of 0. So that's right at the beginning. That's how I know it's my starting point. And then it steadily decreased until we got to this 500 seconds. And at that point, the weight is 0, so the container is empty. Next, we've got a table. So instead of a graph, how do you see the intercepts in a table? Right here. Look for the zeros. Look for the zeros. If a point is on the x or y axis, the other coordinate has to be 0. It has to be 0. So when y was 2,000, x was 0, that is the y-intercept. So the y-intercept, x equals 0, so this is 0, 2,000. The x-intercept, that is when y equals 0, because it's on the x-axis. So the x-intercept is 500, comma 0. So the x-intercept has a y value of 0, and the y-intercept has an x value of 0. Using the labels, this is the exact same problem as last one. So using the labels, the intercepts mean the same thing. The weight started out at 2,000 ounces, and then after 500 seconds, it was empty. The container was empty. Okay, now we are going to teach you how to use an equation and find those intercepts. You notice in my t-chart table over here, I've got only zeros filled in, once for x and once for y. So if I plug in 0, see if you can follow what I'm doing with my equation here. If I plug in 0 for x, I'm solving to figure out what y is. So I've got my train tracks. 3 times 0 is 0. 0 minus y equals 6. I'm going to put a 1 in front of this. 0 minus 1y means negative 1y equals 6. Divide by negative 1, and y equals negative 6. So when x is 0, y is negative 6. That gives me an intercept right here on the y-axis at negative 6. Now, to find my other intercept, I am simply going to plug in my 0 for y. So you plug it in once for x, and then you plug it in once for y. So all we're going to do is find 2 points. So 3x minus 0 equals 6, because I've substituted my 0 for y now. 3x minus 0 is just 3x. 3x equals 6. Divide by 3, x equals 2. So my x-intercept is 2. So on the x-axis I have 2, and then I can draw my line. So I don't need 5 ordered pairs, I just need 2. 1 intercept on each axis, and I can draw my line. Okay, one more like that. Put the 0 for x, and solve. 2 times 0 is 0, plus 5y is just 5y, divided by 5, and y equals 2. So my y-intercept is 0, 2. Now my x-intercept, I'm going to put the 0 where the y is, and solve. 5 times 0 is 0. 2x plus 0 is just 2x. So divide. 10 divided by 2. X equals 5. So 5, 0. On the x-axis, 5. 5, 0. Draw your line. Just like that. You're ready to write your summary now, so go back to your essential question and answer it with complete sentences. And here's your homework assignment.